Welcome to MySci Unit 23, Celestial Clocks and Calendars. This is the 5th grade Earth and Space Systems unit, where students investigate objects they can see in the sky and patterns they can use to mark time. Let's take a look into the unit at a glance. This unit covers several 5th grade Earth and Space Science standards about the appearance of objects in the sky and patterns related to day, night, and seasons. It also covers physical science standards about light and gravitational force. All but one of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. If you'd like, take a moment to pause the video and review them. This unit is divided into 3 sections. Each section has a driving question designed to reflect what we anticipate students would naturally ask through their learning process. Section 1 includes 2 lessons and has an anchoring phenomenon related to the appearance of objects in the sky. Section 2 has 4 lessons, and Section 3 has the final 2 lessons of the unit. Sections 2 and 3 have an anchoring phenomenon connecting the patterns of objects in the sky to telling time. Overall, the unit should take about 32 to 34 days to complete. The anchoring phenomenon for Section 1 is, for centuries, humans have observed objects in the sky. Students investigate the objects we can observe in the sky, including the sun, moon, planets, and stars. The driving question for Section 1 is what makes objects in the sky look different? Students connect to the anchoring phenomenon by engaging in investigations to explain how we can see illuminated objects in the sky. They specifically focus on the moon, the sun, the stars, and planets in the sky. They discover how some stars are brighter than others. The section concludes as students construct an argument that there are differences in the brightness of the sun versus other stars due to their relative distances from Earth. Through the storyline in Section 1, students gain an understanding of these standards-based big ideas. A system is a collection of objects that interact, and our solar system is composed of the sun, moons, planets, asteroids, and comets. Sometimes we can see the sun, moon, stars, and planets in the sky. The sun and other stars give off their own light. The moon and other planets reflect the light of the sun. Some stars look bright because their relative distance to Earth is closer than that of other stars. Other stars appear equally bright even though they are many times farther away from Earth because they have high luminosity. Section 1 should take about 7 days to complete. The anchoring phenomenon for Sections 2 and 3 is, for centuries, humans have used patterns of objects in the sky to tell time. Students dive into the study of celestial objects like the sun, moon, planets, and stars, examining how they shape our understanding and measurement of time. The driving question for Section 2 is how can we use patterns in the sky to tell time? In this section, students connect to the anchoring phenomenon by designing sundials and using graphical displays to explore shadows. They use a model to explore Earth's rotation. Students then represent data in graphical displays. They use a model to explain how Earth's revolution and axial tilt causes this pattern and use a planisphere and a stars through the year model to track star patterns over time. The section concludes as students observe the phases of the moon and use a model to explain this pattern. They obtain information about how ancient civilizations developed clocks and calendars based on these patterns. Through the storyline, students gain an understanding of these standards-based big ideas. Shadows change throughout the day. Longer shadows indicate morning and evening. Shorter shadows indicate midday. Shadows fall from west to east over the course of a day. These patterns are caused by the Earth's counterclockwise rotation on its axis. Earth's counterclockwise revolution around the sun and tilt on its axis causes yearly seasonal patterns, including changes to daylight hours and the location of the sun in the sky throughout the year. The driving question for Section 3 is how can we explain the patterns in space we observe? In this section, students investigate how Earth's gravity affects objects near its surface and discover the Sun's gravity affects planets in our solar system. Students then interact with a gravity simulator and identify how the Sun's gravity causes the planet's orbital motion. This results in some of the patterns observed throughout the unit. The unit concludes as students use what they have learned to develop a narrative depicting a fictional civilization and how they used patterns in the sky to keep time. Through the storyline, students gain an understanding of these standards-based big ideas. The Sun's gravity affects planets in our solar system, and objects on Earth are pulled toward Earth's center. Students support an argument from evidence about the effect of gravity on Earth. They learned how gravity affects the motion of objects in space, which causes the patterns we see on Earth. Section 3 should take about 10 days to complete. Our team here at MySci hopes you and your students enjoy celestial clocks and calendars and engaging in work around these exciting space and culture concepts. We look forward to your feedback. Happy MySciencing!